I'm Tijan Mori. Here, my colleague is Tipot Bryson. So our project, we are mixing plastic bottles and graphite. So, tumatenga ma plastic bottles, after shredding them, we have to melt them. After melting them, tumabanga mix the graphite. So the question can be, why this project? There's a need for sustainable and low-cost engineering materials here in Malawi. So we have to solve that problem. So our main objective was to produce recycled PET graphite composite. Immediately we tumabanga produce the ufa maboro ila ubanga shred. So after producing graphite, the mafrex tumabanga test physical and mechanical properties of the composite with varying concentration of graphite in PET matrix. After that, we were comparing the physical and the mechanical properties of Vesconte, nylon and PET graphite composite. Okay. So, in our industries, my bearings in my bush, I'm using nylon and Vesconte. So these materials now they are expensive. So we are trying to find an alternative cheap material to replace these many. That's why I do banga project many. So my project many do my banga cheap band. First of all, we had to shred my plastic bottles. After shredding them, we had to mix with graphite. So Mabanga collect my plastic bottles, then melting temperatures, it was 270 degrees Celsius. We were using my furnaces here at the Civil Lab. After doing the mixing part, tikabanga produce composite, timabanga test ma 4 tests. We had rock hardness, compressive testing, machinability, and water absorption. So first of all, tumabanga sample preparation testing, my results, then tumazabanga compare the standard emery in IFL. So tumazabanga produce optimal. Tikabanga compare the nylon and Vesconte is in this many zero guy. I nenga the standard IFL. Yeah. So we now my colleague contains Snanga. We are doing 2 projects.
Yeah, so the main issue here is that we are producing a composite which its properties can mimic nylon and Vesconte. So we are changing the amount of graphite which we are going to add to the PET, and we test them. And we carried 4 tests, hardness test, we carried machinability test, we carried water absorption test, as well as a compressive test. So we came up with graphs, and after analyzing the compression test, we find out that the sample number 3, which has got the graphite of 5%, has properties which mimic the nylon as well as Vesconte. So this sample has got 5% graphite, which means it has got 95% recycled polyethylene terephthalate. This one, among those samples, has high compressive strength of 68 megapascals. So it means this sample mimic the characteristics of nylon, because nylon has got compressive strength of 70 up to 90 megapascals. From there, we did the water absorption tests, in which we took our samples here and we put them in a water bath maintained at a temperature of 25 degrees, and we waited for 24 hours. After 24 hours, we took the mass of these samples and we plotted a graph, and the graph showed that as we are increasing the amount of graphite in these samples, the water absorption is decreasing. So according to the graph, the sample which has got optimal in terms of water absorption is that sample with zero graphite. And we did hardness, Rockwell hardness test, and after we plot a graph, from the graph we could read that as we are increasing the amount of graphite, the hardness is increasing, but a point is reached whereby the hardness is decreasing. So at a sample with 7.5% graphite, the hardness started to decrease. The final test which we did was smoothness test. We machined our samples using lathe machines, and after that we used their surface roughness comparator to find the smoothness in terms of RA. And we find that as we are increasing the amount of graphite, the smoothness of our samples was increasing. So it means as the more we add the graphite, the rougher the sample is becoming. So after all of these tests, we came up with a sample which has got properties which mimic nylon and Vesconte. And that sample is this one, a sample with 5% graphite as well as 95% recycled polyethylene terephthalate. So how important is our project? After finding the optimum combination of graphite and RAPET, we are able now to find an alternative material which we can use to place nylon and Vesconte. And this alternative material is the one which has got 5% graphite and 95% recycled polyethylene terephthalate. Key challenges. The challenges which we met when we were doing this project. First challenge was limited local testing resources. We carried 4 tests, of course, but we plan to have more tests. We plan to have tensile tests, we plan to have weir tests, but because of lack of testing machines for these properties, we didn't carry out that. Second one was testing limited to short-term conditions. For example, we did water absorption. We took our samples and placed them in a water bath for 24 hours, and we took their mass to find out how much water has been absorbed. But we can do the same maybe after a week or after a month. So those are some of the challenges which we face during our experimental project. The recommendation, we recommend that if some people decide to come and do the same project, we recommend them that they should at least try other fillers. In our case, we are combining recycled polyethylene terephthalate, RAPET, with graphite, but some can choose to use other fillers like natural fibers, etc. And another recommendation is that when other people want to do the same project, they will have to carry their test for a long period of time. In our case, I've already said that the tests, like water absorption test, was done within a day, but if some people come along, they can do the same, maybe for a week or for a month. The last recommendation is the use of advanced processing techniques. In our case, to combine RAPET and the graphite, we use a technique which is called melt processing. We melted first the RAPET at 270 degrees Celsius for 3 hours. After that time, we added graphite and we waited for it for an hour. But the technique, there are so many techniques. There are extrusion, there are intrusion. So we recommend that if some people decide to do the same project, they can use other techniques. So In general, our project has or will help to find a cheap material which will replace nylon and Vesconite, because nylon and Vesconite, they are expensive, and by using this through this project, we are going to find a cheap material which can replace these two, Vesconite and nylon. Yeah, we are planning to make money out of it. It's not that we just want to get the degree. No, the plans are there, such that when we leave, we should at least in the future carry some other tests and find out more about this sample. Our target market are industries which produce bushes, bearings, wheel parts, and those companies which produce automobiles. Yeah.